Hello, my name is Nigel Griffiths. I work in the Advanced Technology Centre in the UK, part of IBM Europe. This is one of three small movies that we're looking at some of the misunderstandings about power processors. And in this movie we're going to answer the question, how many CPUs is there in a power chip? The power chips, currently Power 6, are made on a wafer. Rather a nice piece of silicon here. And we find that this is round about a foot across, or 300 millimeters to be more exact. On this wafer then we create roughly 120 chips in one go. And I've only worked out the 120 by trying to count up the number of whole CPUs I can actually see on this particular wafer. Now it's difficult to see individual chips here, so let's zoom in on a piece of this wafer. It's still a little hard to make out the individual chips unless you know what you're looking for. So let's cut these chips up as we would if we were trying to put them into individual packaging to put them into machines. Again, it's difficult to see some of the details in here, so let's take one of these and zoom in yet again. So here we have an individual chip, a Power 6 chip that goes into our current range of machines. Okay, well let's now focus on the CPU itself. If you look at this carefully, you might decide there's four sorts of areas, one in each of the corners, that look roughly the same. Now, unfortunately they're not CPUs, that's the level 2 cache in four different areas in each of the corners. The actual CPUs are here. So there are two CPUs, or central processing units, or two processors on this individual chip. And there they are. Let's have a look at what else is on this chip. First, there are two level 2 controllers, one for each of the CPUs, and it uses this to access its level 2 cache. Then there are two level 3 controllers, and a level 3 controller is used to talk to the level 3 cache, which is external on the power chips. Then there are two memory controllers. These give us the access to the actual memory inside the machine. In the middle here we have the I/O controller, and as you can see there's quite a lot of space left on the chip here, which we haven't actually told you what it's for. Well, the rest of this is for the interconnect switch fabric. This gives us the way we can communicate directly from this chip to the next chip in the machine. And all the hard work is actually done in the processor itself, so we can just join copper tracks from this chip to the next chip, and they can instantly communicate with each other over this switch fabric. It also has the interconnect to go to further chips further away, so we can join the whole machine up together and make a single SMP image. Now you may have noticed, if you look at the current range of machines, we also sell one CPU machine. So how do we do that if every chip has two CPUs? Well, the answer is one of those CPUs is not working, and you could use any of these words to describe what's going on depending on how cynical you want to be. It does mean though that we can reduce the price of our very low-end machines and make use of those chips where we find that one of the CPUs won't work at the full speed. We simply switch it off and then ignore it. So to answer the question directly, the answer is 2. We have two CPUs on each power chip. This is true for the Power 4, Power 5 and Power 6 computer ranges. Now there is some difference of opinion in the industry on what you actually call these. Now I tend to call things CPUs because I've been using that term for 20 to 30 years now. Some people prefer the processor name. And we also have this new word that people are using now as cores, and I tend to regard these all as the same thing on our power processors. If you're a system builder, people also refer to how many way a particular machine is. So in this case this would be a two-way machine, would have a single power chip. Now we did confuse a few people by the way we package the Power 5 chips. First of all, we use this thing called a dual chip module, or DCM. This is a 2-inch piece of ceramic in which we put two chips. One chip is the power chip and the second chip is the level 3 memory cache chip. So these dual chips aren't two power chips, there's only one power chip in a dual chip module. This gives us one chip, so two CPUs or two cores. Later on we produced a quad chip module, again in about a 2-inch ceramic module, and this has two power chips and two level 3 memory caches. So those two power chips have two CPUs each, so that makes 4 CPUs or cores. In the top end machines we use this thing called a multi-chip module that's quite a bit bigger. As you can see in the diagram, with the hand behind it, is about 4 inches across. In the center you can see the 4 power chips. You can also see that each chip in the middle there is turned around by 90 degrees. And this means we can actually join the copper tracks directly between each of these chips and make a loop, and they can all communicate with each other very simply. On the outside we see the 4 level 3 memory caches. So here we have 4 power chips, each with 2 cores, so that makes it an 8 CPU or 8 core multi-chip module. If we put 8 of these multi-chip modules into one machine, we then have 8 times 8, it's a 64-way machine. It will, however, only have 32 power chips in it. And this is how we built the PowerBasics 595 model machine. Now in PowerBasics things are a little bit simpler. We tend to use the dual chip module technology throughout. So we have one power chip and one level 3 memory chip, and out of it we have then 2 CPUs or 2 cores. There are a couple of exceptions there. On the very low end modules we leave out the level 3 cache. This reduces the performance a bit, but it also means that we can reduce the cost, so we have a very low entry point if you want the very small machines. And on the top machines, the 595 at the high end, we actually put 2 level 3 cache chips for every power chip. Remember we had 2 level 3 controllers? Well, we use both of those in that case. This gives us extra bandwidth to our level 3 cache and gives us a boost in performance. So there's the answer for you. How many CPUs in a power chip? The answer is 2. It's the same for Power 4, Power 5 and Power 6. Hopefully that's nice and clear and we've cleared up any confusion. So if we have a machine, how do we determine the number of physical CPUs? Well, there's 3 cases really. First of all, if you're a standalone machine, you're just running a single copy of AIX and all the CPUs. Then if it's a HMC controlled machine running logical partitions, we can find out the physical CPUs from the HMC itself or from within a logical partition, and we'll have a quick look at those now. If we have a simple machine just running a copy of AIX, this is called the standalone environment, then we can use the lsconf command to tell us how many CPUs are available and a whole load of information as well. I'll put that through PG because there's lots of lines of output. At the top here we can see the sorts of machine we're running and the sorts of CPU, and we look at this line here, the number of processors is 4, so we have 4 physical CPUs in this machine. We can also double check that this isn't running in logical partitions. This lpar info is -1 and null, proves that this is not a logical partition environment, and we have a single copy of AIX running on all CPUs. If we prefer to do that in a single command, we can use the lsdev command and ask it to tell us about the processors. In this case here we can see all 4 CPUs and we could count those in a script, for example, but we do have to make sure that they are switched on, they are available, so we have to check that they're in the available status. If you want to find out the number of CPUs on your machine and it's controlled by a HMC, the best way is to go to the HMC, as you can see here. If we click on Systems Management, and then we click on Servers, we get a list of the servers controlled by this HMC. This HMC has 5 machines, and here they are. And if we look in the configured processor units, this is the number of physical CPUs on these machines. The first 3 have 4 CPUs and the last 2 have 8. We can also see here available processing units, so these are the processing units that haven't been assigned to logical partitions yet. And we see similar numbers here for the memory on the machine and the amount of memory that hasn't been assigned yet. If we log into one of the logical partitions and use the lparstat-i command, as we see here, we get a lot of useful information about a logical partition. And the important thing to note is these two lines here, the maximum number of CPUs in the machine and those that are actually online at the moment. So this machine has 4 physical CPUs. Now while I'll leave you to have a look at that, there are some other things that confuse people, particularly when we talk about SMT and logical CPUs, and when we're using the shared CPU logical partitions. People can get very confused about what all these different numbers and performance things means in terms of entitlement and virtual processors. And we'll look at those two items in different movies.